Everyone, in this video, I'm going to go through 6 examples of polynomial equations that should reflect the same questions you're seeing in your assignment over solving these equations. So if you get stuck on a particular question, I recommend you just jump to that part of the video and try to mimic your steps with mine and pause the video as needed and rewind as needed to see what it is that you're doing, and hopefully that helps. If not, always know you can reach out with some questions. So let's go ahead and get started. And again, these questions should look just like your homework assignment, just with some different numbers here. Okay, so on number 1, the first issue is our equation is not equal to 0, so we can fix that. I need to subtract 484 to cancel this term over here. 484x, that is, so minus 484x here and here, which will give me 4x to the third minus 484x equals 0, which is exactly what we need. And in this one, there's a step that we usually forget about, and it's that the terms have a common factor. And so that's something we always want to check. A lot of times that makes our problems workable. And so here, as I'm viewing this, I see that both terms are divisible by a 4, but also they both contain an x. Okay. And so in this one, when we divide out this 4x, I figure out what I get next. 4 divided by 4 is 1, and x to the third divided by x is x squared. So I get 1x squared here. And then negative 484 divided by 4, that is negative 121. And then the x divided by the x will cancel away. So we just get the minus 120 then there. All right, so before I go any further, just kind of some thought here. This polynomial equation has a degree of 3 because that's our highest polynomial. And because the degree is 3, we need to find 3 solutions. And so now that we've factored, we can think about where these solutions are coming from. One is coming from this 4x, the other is coming from x squared. Easy way to solve this now. Take your first factor 4x, set it equal to 0. Take your other factor x squared minus 121, set that equal to 0, and solve. And so the first one, very simply, I can divide by 4 here and here. And so x will equal 0. And over here, I can solve for x, since it's the only x in the equation, by adding 121 here and here, getting x squared equals 121 now. And I can solve for this by finding the square root of x squared. And remember, x squared gives us 2 solutions. So when I take this square root, I get x equals plus or minus 11. Okay, and so I have 3 answers here. I have 0, positive 11, and negative 11. So I could write my answers all out separately. And so we could show the solution set like this, where I have the 3 answers listed within the set as separate values, or we can use that notation with the plus or minus sign anytime we have answers where we have the positive and the negative. So the other options take x equals and put 0 plus or minus 11. Okay, it's a personal preference, whichever one you like. So that should take care of number 1 on your assignment. You should have one very similar to that. And same goes for number 2. So looking at this one, y to the third plus 5y squared equals 81y plus 405. The same issue as number 1. It does not equal 0. We fix that. This is a positive 81y, so I subtract to cancel. This is a positive 405, so I subtract to cancel. And on the other side, since I'm solving an equation, whatever I do on one side, I do on the other. Okay, and from there, we know these are going to cancel away. So what do we have on the left side? We have y to the third plus 5y squared minus 81y minus 405 is all equal to 0. Okay, so we have equals 0 there. All right, so just like last time, I'm looking at the degree now. I want to think about how many solutions I'm finding. So if my highest exponent is 3, that means my degree is 3. And because my degree is 3, that means, once again, we need 3 solutions from this polynomial. So how do we find those solutions? By factoring here, we could look for a common factor like we did last time. We don't have one. We can't divide them all by a numerical value, and they do not all have a variable. So if we look here, though, we have 1, 2, 3, 4 terms. And because of that, we can do what's called factor by grouping. So this is where we look at our first half and second half separately. And so if we divide this polynomial into 2 halves, let's look at our first half here. In the first half, I see that they have the variable y, and it looks like we can bring away y squared from each. And so they have y squared in common, divide by y squared here, and I get y. Divide by y squared here, they cancel, and I get plus 5. And so your polynomial should do something very similar right here. On the other side, these have something in common. And remember, whatever we divide by, we want to get this quantity of y plus 5 again. And so we need to divide by a negative. And another way to know that is your group starts with a negative. And I'm going to try an 81 here and here. And I think I'm going to be lucky enough. Dividing by negative 81, I get y equals plus, and it turns into a 5, which is good. And so now we've done that, we see that the 2 halves both have a factor of y plus 5. And so that becomes a factor of my polynomial here. And your second factor is going to be whatever we brought out from each half. So this y squared minus 81 will become my other factor here. And that is equal to 0. And now that we have our factors and we can isolate y in each of them, because there's only the variable y written one time in either one of these, we should be able to set our factors equal to 0. So I will take my y plus 5 equals 0, and also y squared minus 81 equals 0. And a quick solve here, subtract 5, and I get y equals negative 5. And on the other side, adding 81 gets y squared on this side of the equation equal to 81, and I can take the square root here and here, and I get y equals, remembering that y squared gives me 2 solutions, I'll put plus or minus, square root of 81 is 9. And so there are my 3 solutions. I have a negative 5, I have a positive 9, and a negative 9. And so in that shorthand notation, I could show my solutions as negative 5 plus or minus 9. Okay, so that should take care of the first 2 questions on our assignment. Jumping down to the next 2. Looking at number 3, we have a trinomial here, or we will very soon. The equation is not yet equal to 0, so I fix that. I look at my value, it's a negative 144. So I need to add 144 to cancel. If I'm going to add 144 on that side, I'll add 144 on the other. And there's no like terms when I do that, so I'll write the 3 terms separately. And I get the trinomial x to the 4th minus 25x squared plus 144 equals 0, which is what we need. So for this one, I'm going to go through splitting the middle. And for the next example, I'll show us the quadratic formula again. We can do either in these scenarios when we have 3 terms. But let's go through split the middle, which is find 2 numbers to break this middle piece apart. And so for that, we quite often made a chart. And in it, one side said multiply. Let's give myself more room there. So multiply. And the other side, we either write the word add or combine. Same idea. And for this, we say multiply is a times c, which is 1. Our a value is 1. The leading coefficient is 1 times c is 144. So when we multiply, a times c is 144. And then on the B side, on the add side, we use B, which is negative 25. And because of that, I realize I need two numbers that multiply to a positive 144. That means their signs have to be the same, both positive or both negative. But if I'm going to combine to this negative 25, I need two negative numbers. And so you can go through, make a list of all of the integers that would multiply to 144, which I'll do now. And so I've created my list of options of integer values that will multiply to positive 144, and they're both negative. And only one of these scenarios will combine to negative 25. If I come down here, I get negative 9 and the negative 16 are going to do that. And so those are the two terms I will break apart here. This 25 will break down to negative 9, negative 16. What we put after that needs to match what's in the middle, and so I need to put x squared on both of these, because when we combine like terms, the exponent stays the same. The polynomial still starts with x to the fourth, still ends with plus 144. And now we're back to what we did in example 2. We have four terms, so split in half. What does the first term have in common? They both have x's, and we can take x squared away from both. They have x squared in common. So divide by x squared, and through my division here I get x squared again, and here the x squareds cancel, so we have minus 9, and we're hoping to get that minus 9 again. And so on this side, we need to get the parentheses to match the x squared minus 9. And so something to look for is the parentheses need to start with positive x squared. Well, the only way for that to happen is if we divide by negative 16 here, which means we'll divide by negative 16 here. And showing that minus 16 right there in the middle, we brought it out. Good news is we get x squared minus 9 again. And we have this common factor, which is good. So that becomes one of the factors of our polynomial, x squared minus 9. The other factor, again, is what we had brought out from each half. So we get x squared minus 16. And from there, solving is as simple as writing x squared minus 9 equals 0. And x squared minus 16 equals 0. Okay, and so remember, I skipped this, but the number of solutions we're going to need is based on our degree. If our highest exponent in this equation is 4, this equation is degree 4, polynomial degree 4, meaning we need 4 solutions. Where are those solutions going to come from? Well, this first equation has x squared, so 2 from that equation. This other equation also has x squared, so 2 more from that one. Okay, so let's solve this. Adding 9 and adding 9, and we get x squared equals 9. And then when we take the square root, we're remembering x squared gives us 2 solutions. We represent that with plus or minus, and we get 3. The other is x squared minus 16, so we'll add 16 on each side, and then we get x squared equals 16. Just like before, we evaluate the square root. We recognize x squared should give us 2 solutions, so we put plus or minus down. Square root of 16 is 4, and there are the 4 solutions we need: positive 3, negative 3, positive 4, and negative 4. And we can write them all separately, or write them in the plus or minus 4 format: plus or minus 3, plus or minus 4. Just a shorthand notation to show all 4 solutions. Okay, so let's try another example like this. Another trinomial, that is. Notice the equation's already equal to 0, but instead of solving this one by factoring, let's try the quadratic formula. Maybe that's something we're a little more familiar with. Just as before, we check the degree, and in this case, the degree equals 4. So for us, that means that we need 4 solutions. Okay, so let's go ahead and find those. The quadratic formula, says x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, this is set up for a quadratic equation, but we have a quartic equation degree 4, so we have to alter it just slightly. You check your middle term. If it says x squared, we write x squared. Okay? But otherwise, everything else is going to work the same. We get x squared equals, we substitute in, our a value is 1, our b value is positive 3, and our c value is negative 28. And we get that from the coefficients of our equation. Okay, so when we substitute, let's see what we get. For negative b, we have negative 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 28 all over 2 times 1. And again, all I did was substitute my values for a, b, and c. And then simplifying this, we can look. We have negative 3 in the beginning, plus or minus. And then remember on a scientific calculator, such as Desmos, you can type in all of these values underneath the square root sign at one time. I strongly recommend you put parentheses around things to make sure the squared part works out correctly. But type all of this in and you'll get a value. So again, don't type in the square root, just everything that's underneath the square root, and you'll figure out what number you get. In this case, it's 121. Okay, and divide that by 2. 2 times 1. Okay, simplify one more time. Good news here is in this case, we know the square root of our value. Square root of 121 is just 11. So I put that here. And now that we've simplified, we break into our two cases. So this is going to lead us to x squared equals negative 3 plus 11 over 2, as well as x squared equals negative 3 minus 11 over 2. Okay, and so to get our 4 solutions, 2 of them are going to come from this equation that has x squared. 2 more will come from this equation where we have x squared. So let's simplify a little bit more. We get x squared equals, in this case, that is going to be 8 over 2. So x squared equals 4. Square root here and here, x equals, our 2 solutions are plus or minus 2. The square root of 4 is 2. Okay, so this other scenario, we get x squared equals negative 14 over 2. X squared equals negative 7. We evaluate the square root here and here, and we get x equals our 2 solutions, plus or minus, and we have the square root of a negative. And so we need to remember that square roots of negatives result in imaginary values. So we get plus or minus imaginary square root of 7. So we show that with I square root of 7 and put that I before the square root. That's helpful. And you check your square root. We do not know the square root of 7, and 7 is a prime number, so it does not break down, meaning we don't need to simplify this square root. We are finished. Here are our 4 solutions. We have positive I square root of 7, negative I square root of 7, positive 2, negative 2, and very simply, when you write your solutions, you can show them in that format as plus or minus 2 and plus or minus I squared root of 7. Okay, and when you're typing in your answers on the computer, there should be a button at the bottom of your screen for a plus or minus sign. Okay, so the last 2 cases are going to involve our perfect cube formulas. So we have 2 of these. Number 5 on your assignment should have the plus of the sum of these 2 cubes, and number 6 should have the difference of these 2 cubes with that minus sign. So just kind of reminding you, these formulas, which you should have available to you, I'll go ahead and write them on the screen here. For this case, where we have the addition of 2 perfect cubes, the factoring was pretty straightforward. It gives us a plus b and times a squared minus ab plus b squared. And for the difference of two cubes, it was very similar to that, where instead we have a cubed minus b cubed, and the factors are the same essentially. We just change a couple of signs, where instead we have a minus b, and then it's a squared plus ab plus b squared. Okay, so both of these formulas actually work out almost the same way. So let's talk about how we fill in for a and b again, in case you've forgotten. A is just what we call the cube root of your first term. So in this case, we have the cube root of x cubed, which very simply is just x. And for b, we have the cube root of 729, which if you go into a graphing calculator or scientific calculator, such as Desmos, there should be a button. It has a little in outside of this radical sign. It looks like an in out in front of a square root sign. Choose that, and you put a 3 in the tail and type in whatever number you have underneath. And for this, the cube root of 729 is just 9, quite a small value. So now that we know the values of a and of b, I just need to plug them into this formula here. So let's go ahead and give this one a try. A plus b is going to be x plus 9. And then a squared is going to be x squared. Minus ab, we get minus x times 9. And then plus b squared is going to be plus 9 squared. Okay. We're going to simplify this trinomial over here. While we did plug in for a and b just like it showed us, we can simplify a little bit because we don't write it as x times 9. Well, more common way would be 9x, and then plus 9 squared, that is plus 81. Okay, if you can get this far, there's not much left to do other than solve, and it's going to use some pretty familiar techniques here, so that's a good thing. We'll take our first factor, x plus 9, and we'll say that can equal 0. We'll take our trinomial here, x squared minus 9x plus 81, and say that equals 0. And that's going to get our 3 solutions, which I realize I neglected again because this is degree 3, right? Our highest exponent is 3. That tells us that we need 3 solutions. Okay, and where are those coming from? We get 1 from our first equation. We subtract 9 here and here. And so we get a solution of negative 9. And then our other 2 solutions come from this one. And we know that because of the x squared. So just a little bit of information for you. Anytime we use these formulas, this trinomial will not factor and cannot factor with integers. So the way we're going to solve these is we're going to use the quadratic formula. And so we substitute here, and we have a b value of negative 9, so we get negative 9 plus or minus the square root of negative 9 squared minus 4 times 1 times 81 all over 2 times 1. Simplifying that, we get x equals, this double negative gives us positive 9. And then we have plus or minus the square root. And again, I won't type in the square root sign into the calculator, but everything else I will, including these parentheses here around negative 9. And I should get negative 243 divided by 2. Okay, simplifying that some more. That's going to give us x equals 9 plus or minus. The square root of a negative number is always imaginary, so we get imaginary square root of 243 over 2. And then we can try the square root of 243. It is not a value that we know, and so that is when we make a factor tree to see if we can simplify it. So 243 could be rewritten as 3 times 81, which 81 we know is 9 times 9. And we know that 9 is 3 times 3. And so if we complete our factor tree, we have five threes at the end of our branches. And so simplifying the square root, so 9 plus or minus I, instead of putting square root of 243, we can show those 5 threes down here being multiplied. And remember, at this point, we're looking for common factors. And so we look for any pairs of factors. We have a pair of threes there and a second pair of threes here. And so for every pair of factors that you find, you'll bring out one of those values. And so we'll bring out a 3 and a second 3 for our two pairs. So we have 9 plus or minus 3 and a second 3 being multiplied. 3 times 3 would give us 9i. And then underneath the square root is this 3 that we did not include, all over 2. And then it's just a quick comparison. We're all finished as long as these 3 coefficients right here do not reduce. And since 9 is not divisible by 2, we actually leave it as is. So we are ready to write our solutions because we found our -9 up here and these two imaginary values here. And so one way we can show this is with -9. Yep, -9. I almost forgot there for a second. So -9, comma, and instead of writing these separately, we can put them together. So 9i squared, 9 plus or minus 9i squared to 3 over 2, recognizing that we get two answers from this, from the addition and then a second answer from the subtraction. Now, you might also see this where these two parts are written separately. So you might see something more like this, where you have -9, and then we split this in fraction into two parts. We write it as 9 over 2, and then plus or minus. Different ways we can do this next part, but we're essentially just going to take this second part of the fraction and write it as well. Different arrangements we could put might look something like this, where we have the 9 square root of 3 over 2, and maybe the I goes off to the side. But it's all the same idea, whether we write it as all one fraction or two separate fractions. And again, when we write it as two separate fractions, we see that 9 over 2 does not reduce. Okay, so let's do one last of these in case you need it. It's just like number 5, actually. So you already know how to do it, but in case you want to see another example, here's our formula. The degree is 3 again, meaning you need 3 solutions. Okay, so to find the a and the b values, remember a is the cube root of your first term. So the cube root of w cubed here is w, and b is the cube root of your second term. So cube root of 343, which is 7. So factoring this, everywhere we see the letter A, we'll replace it with W. Everywhere we see the letter B, we'll replace it with 7. And that gives us W minus 7 times W squared minus W7, W times 7 plus 7 squared. Okay, and our equation was equal to 0. And again, just like last time, we can simplify our trinomial as W squared minus 7W plus 49. And now we're ready to solve it. We'll take our first factor, W minus 7 equals 0. Quick adding 7 on both sides gives us W equals 7. And then on our second scenario, remember this trinomial in the formula will never factor for us, and so we are forced to use quadratic formula. And let's go ahead and get that ready. And you might notice I put w equals on this one since our variable is w instead of x. And so we get then, after substituting our values, w equals negative 7. Oops, hold on. I messed up the formula here, didn't I? So go back. Our formula had a plus sign in these parentheses. So I should have put a plus sign here and here. A little mistake like that could force us to fix some work later. So good thing we caught that early. So plus sign there and there. So here as well. So for negative b, we just have negative and then 7 plus or minus the square root of 7 squared minus 4 times 1 times 49 in this example, and then all divided by 2 times 1. Simplifying that, we get w equals negative 7 plus or minus the square root. Again, type all of this into a calculator. Don't use the square root sign, but do use parentheses just to be safe here. And in this case, I get negative 147. So a negative number like last time, meaning we're going to get imaginary solutions. And actually, this trinomial is always going to give us imaginary solutions. Our denominator is just 2. Okay, simplifying a little bit more, we get negative 7 plus or minus. This is imaginary, and then we'll figure out what the square root of 147 is. It's not a perfect square. You can try typing in the square root of 147 to a calculator. You get a decimal, and so we do a factor tree for 147. And 147 is 3 times 49, and we know 49 is 7 times 7. And so 147 breaks down to 3 factors, 3 times 7 times 7, and we get w equals negative 7 plus or minus imaginary square root of 3 times 7 times 7 all over 2. And we're looking for pairs of factors, and so we see there's a pair of 7s, just one pair of 7s, so we'll just bring out a single 7 from this. And that will give us w equals negative 7 plus or minus 7i squared root of 3 all over 2. And just like in number 5, you can see here that your 3 coefficients, negative 7, 7, and 2, do not reduce. So the answer is good as is. It does not simplify anymore. And we can leave it that way. And so our 3 solutions are 7 and these 2 imaginary solutions, and we can show that. So w equals, here's my solution set. I have 7, and then our 2 imaginary solutions are negative 7 plus or minus 7i squared root of 3 over 2. And again, if there's that alternate format, the imaginary answer might be broken into 2 components, which is technically how they're defined. Not that it's a big deal. In that case, we'll have 7 and then negative 7 over 2 plus or minus. And then maybe the I is with the 7, maybe it's off to the side. If it's off to the side, which would be a standard practice, it'd be 7 followed by the square root of 3 over 2, and then put the I next to that fraction. Both of these mean the same thing. For us, either is acceptable, but if on your homework you're seeing it presented in a different way, here's an alternate to that. So I hope these examples help. Again, just pick and choose from the ones that you need.